S-Chan presents Educational Video Lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Now, when the waves are traveling along the direction of propagation of waves, means when the string is placed in the x-axis and the wave is also propagating in the same direction, what will be the name of that waves? So that we will understand in the upcoming topic.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
Welcome to S-Chan Academy. Myself, Dr. Narinder Kaur. So let us begin this topic. Now, the waves which have the displacement in the same direction as the direction of propagation, such kind of waves are known as longitudinal waves. So that means the longitudinal waves are what? The waves which have the same direction to the direction of displacement and also the direction of propagation. So these kind of waves are known as longitudinal waves. Now, when the wave is traveling in the perpendicular direction, that waves are known as transverse wave. This is another form of the wave which is known as longitudinal waves. So longitudinal waves, these are the waves where the displacement of the medium, we know that in the medium information is passed from one point to the another point. So that means where the displacement of the medium is in the same direction as the direction of traveling wave. So direction will be same. If the medium is placed in the x-axis, then the direction of propagation of wave, that will be also in the x-axis. Both are in the same direction. Such kind of waves, they are known as longitudinal waves. Now, next point is that the distance between the center of two consecutive regions of the compression or the rarefaction is defined as the wavelength. Now, firstly, we will understand these kind of waves are produced in one. Firstly, take a spring and you can fix the spring, stretch the spring and then leave it. We know that in the spring, so it will start vibrating. So the kinds of waves which are produced in the spring, they are known as longitudinal waves. Means we are here taking a spring over here. Now, if this is a spring and it is fixed between the 2 points. Now, we know that when we stretch the spring and then leave it, so the spring that will start vibrating. The waves which are produced in the spring, they are known as longitudinal wave. While the waves which are produced in the string, they are known as a transverse wave. So, we know that the spring that will get compressed, then it will leave from its position. Then it will get compressed. So, such type of vibrations are taken place over here. These vibrations are in the terms of waves, they are known as longitudinal waves. That means there must occur compression and rarefaction. That means compression of the spring will be there and rarefaction of the spring will be there. Again it will compress, then it will release. Compress, then it will release. So such kind of motion will be there. So there will be waves are produced from one end to the another end. Such kind of waves are known as longitudinal wave. Now again, so that means, for example, this is a case over here. So in this case, what will happen? So these kind of waves, these are known as a longitudinal waves over here. So that means in the longitudinal waves, what will happen? So that now we firstly want to take a spring over here. So this spring from tightened between the two ends A and B. Then you can stretch the spring over here. Then the spring that is get stretched over here. When the spring is get stretched and then leave it, you can clearly see that when you can leave it over here, some part of the spring that is get compressed and some part of the spring that is get expanded over here. So such kind of motion will be there. So there occur compression, rarefaction, compression. So that will be the points in the spring over here. Now the distance between these two, now this is a compression over here, again this is a compression and there is a rarefaction. So such kind of motion of the waves, they are known as longitudinal wave, and these waves propagate along the direction of propagation. Now, this is a compressed air. Again, this is compressed over here. Now, the distance between these two compressions, consecutive compressions, that is known as wavelength. That means, now consecutive, why this is there? Now, again, there is a rarefaction. So, the spring that is get compressed, again there is a rarefaction, again the spring is get compressed, again there is a rarefaction. So, the distance between these two consecutive compressions, that is known as, this distance, that is known as wavelength. While in the transverse wave, the distance between two consecutive peaks is known as wavelength. Now, the distance between these two consecutive rarefactions, this is known as wavelength lambda. Now, what is the wavelength of this longitudinal wave? That is the distance between two consecutive compressions or two consecutive rarefactions. This distance is known as wavelength lambda. So, now why there is a consecutive words? Because the wavelength same to the transverse wave, the distance between two consecutive peaks, that is known as wavelength, or the distance between two consecutive troughs, that is known as wavelength. So, here the compression and the rarefaction, these are the two factors for the longitudinal wave. So, that means in the longitudinal wave, now the region of compression or the rarefaction, there is a difference between from the centers of two consecutive regions of compression or the rarefaction, that is known as wavelength. When the compression and the rarefaction regions of the two waves, they coincide with each other. We know that in the spring, so there must be occur when the spring is moving over like this, when it is vibrating over here. So, compression and the rarefactions, they will superimpose on each other. When they superimpose on each other and the regions where they coincide with each other, that is known as constructive interference. And when these regions do not coincide with each other, that is known as destructive interference. Means we are here stretching a spring over here, that means spring is get stretched. So, when you stretch a spring and leave it, so after some time, so there must occur, there is a compression, then there is a rarefaction, again there is a compression, again there is a rarefaction. Again there occur continuous vibrations of the spring like that, that is not at the stable position or the equilibrium position. Now, the continuous vibration of the spring will take place. So, there comes a point when the center of this compression that will coincide with this rarefaction. Means if this, we define this in terms of wave, if this is a wave over here, that means for the second wave, again it will superimpose on this wave. So, that means the center of compression and center of rarefaction, they will coincide with each other. So, there must occur a constructive interference. Means in the resultant, we will get a wave with the higher amplitude. While when the center of compression and the rarefaction, they do not coincide with each other. So, they are superimposed on each other with the different amplitude, or you can say that the opposite amplitude. So, there will occur a destructive interference. So, this is an important point over here. So, longitudinal waves, the waves which are travelled in a spring with the direction of propagation same to the displacement of the wave. So, compression and rarefaction, again compression and rarefaction, when they superimpose on each other, there will be a constructive interference, and when they do not coincide on each other and when their centers do not coincide each other, there will be a destructive interference. So, such kind of waves are known as longitudinal waves. Okay. Now, the longitudinal waves, they can also be defined as a compression waves. So, longitudinal waves, they can be also defined as a compression wave, because compression of the spring that will be done over here. So, that is an important factor over here. So, there occur compression of the spring and rarefaction of the spring. So, these are the type of mechanical wave. Why these are the type of mechanical wave? Because some force is applied on the spring. Spring is either stretched or it is get compressed. So, that is why these are called mechanical waves. Why longitudinal waves are called mechanical waves? Because external force or the mechanical force, external force or the mechanical force is applied on the spring to get stretched or to get compressed. So that's why these are the type of mechanical waves in which displacement of the medium is the same direction as on in the parallel direction to the direction of propagation. So this is the important point here. In the longitudinal wave, the direction of propagation and the displacement both are in the same direction. That means the phase here is given by the angle between the two direction of propagation and the displacement, that will be 0 because both are in the same direction. Now in the longitudinal wave, the motion of particle in the medium, how we can characterize? So what are the properties of the wave? We know that in the transverse wave, the properties like there must be amplitude, frequency, wave number, wavelength, time period and etc. So these are the parameters by which we can define the properties of the transverse wave. See, in the similar wave, longitudinal wave, how we can define or how we can characterize these waves? We know that in such kind of waves, the important factor is compression and the rarefaction of spring. So these can be characterized by alternating regions of compression, rarefaction. So these are the two important factors in order to characterize the longitudinal wave. So compression occurs as particles are pushed closer to each other, resulting in the area of higher pressure and density. That means when the waves, they are get compressed with each other. That means when the waves are compressed with each other. So in this area, spring is get compressed in the smaller part. So that means in the smaller region, the spring is get compressed. So automatically density that will be very high. So these regions are called compressed region. So that means rarefaction, compression occur as a particle and the particles, they will come close to each other. So in this case, they will come close to each other and also the density will be very high because the volume in the small area that will be defined to them in the smaller area. So density that will be equal to number of particles per unit area. Density, we know that that is equal to number of particle per unit area or per unit volume. Now if this is smaller, then density that will be very high. So such kind of region that is known as a compression. So compression occur as a particle are pushed closer to each other, resulting in the area of higher pressure and density. What is a rarefaction? Rarefaction occur as a particles spread apart. So resulting to a decrease in pressure and the density. That means in case of rarefaction, so what is a rarefaction? So rarefaction in this case, such kind of motion that is called rarefaction. So in the rarefaction, particles are get separated from each other and this area that is very large. So automatically density here, the number is N1 upon A. Here is N2 and A2. While in this region A1 and A1. N1 and A1. That means now here the area that will be very large. So automatically density that will be very small over here. So that means D1 that is more than D2. So that means density in the compression region that will be large and here the density that will be very small. So now you can clearly see that. So compression occurs as a particle are pushed closer to each other, resulting in the area of higher pressure and density. While the rarefaction occurs as a particle spread apart, resulting to the decrease in pressure and density. This cycle pattern of compression and rarefaction that will form a oscillatory behavior of the longitudinal wave. So that means how the longitudinal waves are get formed means when compression of the wave and rarefaction of the wave, they travel from one part to the another part. So by combining these two factors, longitudinal waves they get formed. So these are the longitudinal wave. So now we will take a short break. We understood how the longitudinal waves get formed and how the important factors like we can define or we can characterize the longitudinal wave. In the next part and after the break, we will understand what will be the characteristics of the longitudinal wave and how they are different and they are similar to the transverse wave.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Now welcome back to S. Chand Academy. Now we will understand what are the characteristics of longitudinal wave, how they are different from transverse wave, and what are the similarities between longitudinal and transverse wave. So the characteristics for the longitudinal wave that can be defined like this. Now the characteristics. Characteristics means how we can define the wave. We know that any wave that can be characterized by, or the transverse waves that can be characterized by frequency, time period, wavelength, while in the longitudinal wave that can be characterized by the compression and the rarefaction of the spring. Now we know that longitudinal waves, the particles of the medium move back and forth in the same direction. So first characteristics is what? So in this case, we know that firstly the motion of the wave that is same as that of displacement of the particle. So in this case, the particles of the medium, or you can say that the particles of the spring, so they are moving in the same direction as that of the wave. Displacement is in the same direction. This is the first point. Second point, as the wave travels, it forms alternating region of compression, and also in the compression, particles are closely packed to each other. So that's why pressure and density that will be very high at the compression region. And next is the rarefaction. Rarefaction, the particle that will be spread out. So if the particle, they will cover the large area, automatically density that will be small and pressure that will be small. So longitudinal waves, they are formed by the combination of compression and the rarefaction. Now longitudinal wave, they can transfer energy by movement of particle within the medium, and the oscillation of the particle allows the particle to transfer energy. Again, what is a wave? Wave can either be transverse or it can be longitudinal. When the wave travels from one point to the another point, the information that is passed from one point to the another point, that is in the form of energy or momentum. That is same in case of transverse as well as longitudinal wave. So in the longitudinal wave, when the spring gets compressed or it gets rarefaction, means it gets separated out and it gets compressed. So in both of the cases, energy is transferred in the particle from one point to the another point. So that means energy is propagating over here. Next is speed of the longitudinal wave. Now speed of this longitudinal wave, it will depend upon the properties of the medium. That means how it will depend upon the properties of the medium such as density, elasticity, temperature. We know that speed of the longitudinal wave, it also depends upon the elasticity of the spring. If the elasticity of the spring is very small, that means it is not easy for us to get separated out or to get stretch the spring. So in such cases, the longitudinal wave, that will not easy for them to travel. So that their speed that will be lowered down. So speed of the longitudinal wave, that is get affected by the density, elasticity, and also by the temperature. Next is the longitudinal wave, they will require the medium for their propagation. So this is the important point. That means if there is no medium, these waves cannot travel. That means the longitudinal wave that cannot travel in the vacuum, because they need the medium for the particles to be get interacted. Means when in vacuum we are not able to stretch the spring, so longitudinal waves, they can't propagate over there. Next is the longitudinal wave, they have spherical or the cylindrical wave fronts depending upon whether they are originating from a point source, spherical or the cylindrical. That is the same with the light waves. We know that in that case, depending upon the wave front. For example, when the light is originating from a bulb, so that is a point source, we will get a spherical wave front. And when the light is originating from a tube, so that is in the cylindrical form, the wave front that will be in the cylindrical form. So depending upon the shape of the medium from where the longitudinal waves are get originating. That means when the spring length is in the tube, so that means they must have the cylindrical wavefront, and when the spring size or shape that is in the form of point, then we will get a spherical wavefront. So depending upon that, the longitudinal wave that can be spherical or the cylindrical. Next, the longitudinal wave do not exhibit the phenomena of polarization, because polarization that occurs only in the transverse wave. So while in this case, their oscillations, main point, why the longitudinal wave do not have the phenomena of polarization? Because for the polarization to take place, the vibrations of the wave that must be in the perpendicular direction to the direction of propagation. But in the longitudinal wave, these waves travel in the same direction. So that's why they do not occur the phenomena of polarization. So these are the characteristics of longitudinal wave. Now next is what are the similarities between longitudinal wave and the transverse wave. How these two waves are similar to each other. So first point is that we know that both are the mechanical waves, because we have to apply some external force from the outside. For the spring, we either have to compress the spring or stretch the spring. While in case of transverse wave, when on the string, again external force or the jerk is applied so that the transverse waves can propagate. So these are the mechanical wave, and they can transfer energy through a medium without transferring matter. So matter is not transferred in both cases, either the longitudinal wave or the transverse wave. They propagating by cause of disturbance that travel through the medium. So this is the first point. In the second point, we know that there occur the phenomena of interference. For example, in the transverse wave, when the crust of the wave falls on crust of the another wave, so there occur the phenomena of constructive interference. And when the trough of one falls on the crust of the other wave, there occur phenomena of destructive interference. Similarly with the longitudinal wave. That means in longitudinal wave, when the compression of the wave that will falls on the coincide with the rarefaction point, then in that case there occur the constructive interference, and when they do not coincide, there will occur a destructive interference. So depending upon that, at the constructive interference, amplitude increases, while the destructive interference, amplitude will decrease. So we will result in a complex wave pattern. So both of the waves, they will exhibit the phenomena of interference. Next is the speed of both longitudinal and transverse wave. That can be calculated by using the similar principles. That means we know that speed of the wave. How we can calculate that? Speed in either case, either longitudinal or the transverse wave. That can be calculated by lambda divided by the displacement divided by time. So in both of the cases, their speed that can be calculated. Next is the both kind of waves, they can be reflected and the refracted. We know that depending upon the media where the waves get placed. So either these waves, they can reflected back or they can be transmitted. So depending upon the medium where they are placed or how the direction of the reflected wave, they will bounces back from the boundary, while the refracted waves, they will crosses the boundary without changing the direction, while the reflected wave, they will bounces back with a change in direction. So depending upon that, so longitudinal wave and transverse wave, their properties that can be encountered. So these are the similarities between the longitudinal wave and the transverse wave. So that means in some cases, they are same also. So now next is what are the differences between these two waves? Differences between the longitudinal and the transverse wave. So first is the particle motion direction. We know that in the longitudinal wave, the particle motion is parallel to the direction of wave propagation. Both are in the same direction. While in the transverse wave, they are in the perpendicular direction. Next is the wave shape. So in the wave shape, there is a compression and the rarefaction. Compression means high pressure region, rarefaction means low pressure region. So alternative in the direction of propagation. So in this case, there are the crust and the troughs or the valleys or the peaks, they are in the perpendicular direction of propagation. So that means in this case, the information is passes from one place to another place by the compression and the rarefaction. Here the information is passes from one place to another place in the form of peaks or the troughs. That means crust or the troughs or peaks or the valleys from one point to the another point. Here examples are like sound waves, shock waves, all these pressure waves in the fluids, these all are the examples of longitudinal wave. While in this case, the light waves, water waves, strings, the waves which are produced in the strings like on the guitar, on the musical instruments, and also the electromagnetic waves. All these are the examples of transverse waves. Then transmission. Now, we know that there is a requirement of media. So, it can transfer over that. So, these waves can be transmitted from all three type of media, like they can be transmitted from solid, from liquids and gases, while these waves can be transmitted through solids or over the liquid surface. When there is gases are present, the electromagnetic waves or the transverse waves, they cannot travel from one point to the another point. Next is the speed of propagation. We know that their speed of propagation, it will depend upon the factors like density and elasticity, while in that cases, their speed is always remain constant, because throughout the propagation, we are taking that here the speed that is taken as lambda by t. So, throughout the propagation, lambda of the wave that will remain constant always. But here it will depend upon the elasticity and density and as well as temperature. So, that's why speed for the propagation of longitudinal wave is different, because it depends upon the elasticity, while here it will remain constant throughout. Then next is the material medium. We know that for the propagation of longitudinal wave, this is an important point, material medium is required. Without medium, these waves are not able to travel, while the transverse waves, they can travel without medium. So, there is no requirement of medium. We know that in vacuum, light can travel. We can pass the light from one point to the another point. So, light can travel in the vacuum. So, this is a main example for that, while the sound that is not possible to propagate in the vacuum. So, material medium is required for the propagation of longitudinal wave, while for the propagation of transverse wave, there is no requirement of the material medium. So, these are the differences between the longitudinal wave and the transverse wave. We understood what are the longitudinal wave, how they are similar to the transverse wave, and what is the difference between longitudinal and the transverse wave. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.